Hello people of IT 140. Today we are going to talk a little bit about lists and dictionaries. So here we are in Codio or Code.io, however you want to say that. We're going to start off in the terminal. So if you have never launched the terminal from inside, I'm inside the playground now, the personal playground. So you can go in there, you can launch your terminal under Tools, and this gives you, this is a Linux terminal. It's a different operating system. If you aren't used to it, it's not a problem. Somewhere along your journey, you will learn Linux, I guarantee you. But in any case, for right now, this is where we're going to play around with lists and dictionaries for a little bit. Now, as some people have figured out, the version of Python inside the personal playground by default is Python 2. It's an older version of Python, slightly different than the one we're teaching on. We're trying to teach on Python 3, but it's not a problem. Once you go into the terminal, you can hit Python 3, no spaces between Python and 3. And now we are in the Python interpreter. This is an interactive shell to Python. This is where we can start typing commands and see the results. So let's talk about a list. A list is exactly what you think it would be. It's a collection of things. Like you might have a list of phone numbers, a list of people you want to buy Christmas gifts for. If you're Arya Stark, you have a list of people you want to murder. So that's what a list is. It's just a collection of things. We can see a list, we can create a list here in Python just by putting things inside square brackets. So if we want to start off with a list, that is an empty list. We can print it. We have assigned an empty list to the variable a_list. We can print it just like we print any other variable, and there it is. It's an empty list. If we fill a list, though, we're going to reuse a list here. Equals 1, 2. As you can see, all we have to do is put the items in the list separated by commas. We can put any items in there we want. It doesn't matter. They don't have to be sequential. As we'll see in a moment, they don't even have to be numbers. So if we print a list again, now we can see we have our list. 1, 2, 3, 90, 321, whatever we wanted. So now we have this collection of things stored in a variable, and we can use that anywhere we need to. Lists are very powerful. They're used a lot in programming because they're so easy to put things into and get things out of. Now the lists are sequential. They start at the left-hand side and move one by one all the way through to the right-hand side if you need to do that. And we'll see that in a few moments when we loop through them. But before we get there, you can also pull the items out of lists one at a time. So you may have heard that most programming languages are what we call zero indexed. And this is probably the first time you're going to run into that if this is your first programming language. What that means is when you start counting, you don't start counting at 1, you start counting at 0. It's a historical quirk of programming languages. You can look it up if you're interested, but almost every programming language does that. So what that means is if we want to find the first item out of our A list, that's index 0. So if I do this, I come back with the number 1 because that's the first item in the list. If I take index number 1 like that, it comes back with the number 2 because that's the second item in the list. So we have 5 items in our list. We're going from 0 up to 4, right? So if I go and take the 4th index, I get the last number in our list in this case, right? If I try to take index number 5, I get an error. And that's really common when you first start working with zero indexed lists. It's something you just have to remember. It happens to all of us at some point or another. We will go through the last index, and Python is essentially telling us, hey, you've asked for index number 5, but I don't go up that high, so I don't really know what you're talking about. In any case, that's how you can get to an individual item in the list. You get to it by its index, right? Just like that. That's the third index, which in this case translates into the fourth number, number 90. We can add things to the list by calling the append function. So the way you do that is you take your variable, you start with your variable name, a list in this case, dot append. That's telling Python, hey, start with this variable that I know is a list, and I want to append or add something to it. So I'm going to add the number 12 to it in this case. Now the way lists work, they will always add the number at the far right end. Let's see that. And here you see the number 12 got added to the far right end of my list. Sometimes you may not want to do that. You may want to add an item into a list in a particular place. So what you would do if you wanted to add it as the very first item, then that's going to be a list dot insert, right? So what we're doing here is we're again telling Python, take my variable a list, which I know is a list. We're going to insert an item into it. The first thing you want to put is the index, where you want the new item to be. So I want this to be at the beginning of the list. That is always index 0. And now I want to tell Python what I want to put into that index. In this case, I'm going to put the number 100. Right? So I've now inserted the number 100 at the beginning of the list, and you can see it's there at the beginning, and it has pushed everything else to the up one index, right? So that's, kind of those are some of the typical things that you might end up doing with a list. You can also, if you want to, you can tell how big your list is by calling the len function, which is length. In this case, it works a little bit differently. You don't call alist.length. You call len by itself, but then you put whatever you want to check the length of, you put that inside the parentheses. So len of a list is going to come back and give us 7 because we have 7 items, right? Remember, the number of items is one more than the index. So the last index, so the index of the last item is going to be 6. Now that's going to be, see right there, that's the last item is 12. The index is 6. That's because we have 7 items in there and we start counting at 0. That's going to become important at times if you need to loop through this list knowing its length. There are actually better ways to loop through it. We're not even going to look at how to loop through it knowing its length. You can, I believe the exercises show some of that, but there's actually a slightly better way to do it. We are going to loop through this list using a for loop. So, as we learned earlier, when we were doing for loops earlier, we were using them with a range, right? So we would say something like for x in range 0, 10, print x and then we print from 0 to 9, because again, range does not go all the way up to the last element. But we can do the exact same thing using a list. So we can say for, we're going to call it item in a list, print item. Right? And there we go. Python is looping through the list, starting at the beginning, going to the end. Now, in this particular case, we cannot change the order in which it's going to loop through the list. It's going to start at the beginning and it's going to go to the very end. Now, if you wanted to change the order, you can actually use the range function. I guess we will take a look at it. Let's do that real fast. So if we did something like for item in range 0. Now, we have to be really careful here. This is where we want to say we want to go to the length of the list. In this case, we're going to go to the length of a list. But remember, and this is where it gets a little confusing. The length of the list is 7, right? But range is exclusive. So if what we're saying here is let's go from 0 to 7. But 7 does not get counted in the range. It only goes up to 6. So remember that we are only going, that when we put the length in the range here, that last number is not actually going to be included. But that's okay, because we're starting with the 0 index, so we only want to go up to 6 in this particular case. So let's take a quick look at that. So what we're saying here is we're going to take a range from 0 to 7 exclusive, which is going to go from 0 to 6. All right. We're going to call every time we loop through that, we're going to call that thing, the variable, we're going to call it item, right? And so what we want to print here is our list. But remember how earlier we looked at the different indexes? You could manually say a list sub 0 is going to be the first element, a list sub 1 is going to be the second element in the list, that type of thing. Here, what we're going to do is we're going to say a list sub item, and what that'll do is that will substitute the value of item for each time it goes through the loop. So it'll start with 0. The first time through, item is going to be 0, so it'll pull out the first element of the list. And the second time through, item is going to be 1. It's going to pull out the next element of the list, on and on, and it will print out and that's another way to print out the entire list. Like I showed above, this is not the best way to print out a list if you're going to go straight through from beginning to end. However, if you only want to print every other item in the list, the range function lets you throw in what's called a step. So if we say, in this particular case, we're saying, okay, we're going to take a range from 0 to the length of the list, which is 7, right? But we're going to take it 2 steps at a time. We're not going to go every item. We're going to go every other item. Right? So, and we're going to print a list sub item. We're going to spell it right. And there we go. We're starting at the first item. We print that. We print the first item, but then we skip, and instead of going up by 1, we go up by 2. So we print the first item, then we print the third item, then we print the 5th, then we print the 7th. We can also do steps of 3, where we're only printing every third item, right? That type of thing. So that's one way to go through a list. If you know that you don't want to hit every item in the list, you only want to hit every second item, every third item, every 20th item, however that needs to be. That's one other way to go through the list and pull out the items that you need. If you know you're going to need every item in the list, starting at the beginning and going all the way to the end, then the easiest thing is just to do this, right? That's the easiest form, just for every item in the list, and then print that out. In this case, what it's doing is it's going through and pulling that, Python is pulling the first item directly out of the list and bringing it in. All right. Now, we have been working a lot with numbers, with integers. Lists can actually hold anything. So we are going to come up with a new list. Right, so now we have a list of strings, and we'll do the same thing for item in B list. Right, here is the same thing. This is where Python is going through every item in the list one at a time, and we're just printing it out. You could do anything you need to with it, but we're just printing it out. The range would actually work here also. So if we wanted to do item start with 0, we don't have to start with 0. We could actually start with 1. We can go to length B list, and if we just do it like that, we want to print. In this particular case, remember, you're not printing the item, because the item is just a collection of numbers, right? What we're wanting to do is dig into the list and get the element out of the list that corresponds to item in this case. All right, so we're digging into B list and pulling out the in this case item at index 1, because that's where we're starting. So that's actually going to be the second item in the list, and then it'll just print Scott and Gabe. So hopefully that's a little more insight into how to sort of work with lists directly. Lists can actually get a little more complicated. There's some code inside the module for this, inside the unit. I've pulled it over here into the personal playground so we can play with it a little bit here and walk through. The idea here is that we are creating a list of lists. So just like you can put numbers in a list, you can put other lists in a list. So if we go through CList, we're going to call it CList. And the first item in CList is a list of numbers 1, 2, 3. The second item in CList is a list of strings. Derek, Scott, and Gabe. All right. So if we take CList and we want to pull the first item out of that, in this case, the first item in CList is itself a list, the list of numbers 1, 2, 3. If we want to pull the second item out of CList. That is also a list of strings, Derek, Scott, and Gabe. Now, if we want to pull the first item out of that list of strings, right? So the list for inside CList, we're pulling out the second element, right? But if we want to pull the first name out of there, that's how we do it. Notice this form of the list. What it's doing here is saying, okay, start with CList, dig into CList and grab me the first or the second element inside CList. Now, since you know that the second element inside CList is itself a list, you can then tell Python, now that you have this list, dig into it and pull me the first element out of there. So that's what this is doing. It's saying dig into the list and pull the second element, first index, then dig into that list and pull the first element or the 0 index. All right. What we're doing over here, again, this is code that came from the unit. Let's walk through it a little bit so we can maybe make this a little clearer. What we're going to do is we're going to create a list that has 5 rows and 4 columns. So think of this as an Excel spreadsheet, right? You have 5 rows, which will have whatever pieces of data, and there are going to be 4 different columns, right? So it's going to be row, in Excel it'll be 1, 2, 3, 4, 5, column A, B, C, D. We're going to end up storing the same type of thing inside Python, although it's not going to look like an Excel spreadsheet. But we're still storing data as rows and columns in our. So what we want to do first is for x in range of 0 to rows, right? So it's from 0 to 5. We're going to just go in there and add an empty list. So by the time we get through here, what we've got is a list that has 5 empty lists in it. Then what we want to do is go inside, well, let me back up a moment. What we're starting with here is, because these are nested, we're going to start from 0. We're going to go up to rows, to the number of rows, which is 5. The first thing we're going to do is take as the first element in the list, the 0 index, we're going to add an empty list. Right? So when we get here, we have a list called data that has 1 empty list inside of it. Then we're going to take that empty list and we're going to append x and y to it. We're going into this nested loop here. So we've got this first loop that goes from 0 to rows, and then inside that loop is another loop. That loop goes from 0 to columns. Now when you have nested loops, what ends up happening is the first time you go through the outer loop, then you hit that inner loop, it goes through the inner loop every time, and then it breaks out of the inner loop and hits the next part of the outer loop. So we're going to essentially right here, up here, we're starting with x equal to 0. Right here, we're going to go y equal to 0 all the way up to y equal to 3, because we're going up to columns, but it's exclusive, so it doesn't actually go all the way up to 4. It goes from 0 to 3. We're going to go through this inner loop, 0 to 3, completely. Then we're going to go back up to this outer loop, hit the next value on the outer loop, which will be 1, come back in, go through this inner loop completely again, then back up to the outer loop, hit 2, all the way through until we have exhausted the outer loop, and for every time we've gone through the outer loop, we've gone through every iteration of the inner loop. So what this means is So we're going to start on the outer loop. X is equal to 0. So by the time we get down here, what we're saying is we're going to add data. We're going to add into the data list at element 0 or index 0. We're going to add this information, right? We're going to take whatever X is, we're going to turn it into a string, we're going to concatenate it with a comma, and then concatenate that to whatever Y is that we have turned into a string. So, and then we're going to print it out. Let's run this. If you hit run current, it will give us a new terminal, and you can see here, this is our output, right? So inside, this is the main list right here, where it starts with that first open bracket. Inside there, we have a list that goes from 00 to 01, 02, 03. That represents the first time through both the outer loop and the inner loop. The first 0 is X, the second 0 is Y. Over here it's X is 0, Y is 1, X is 0, Y is 2, X is 0, Y is 3. That's the first time completed through the outer loop. Then on the next time through the outer loop, X becomes 1, Y gets reset to 0, then X is still 1, Y is now up to 1, X is 1, Y is 2, X is 1, Y is 3. That's the second complete time through the outer loop, and then we go another time, and another time, and another time, until we complete everything. So, it might be a little easier if, instead of just printing the data, why don't we do this? Put this inside a for loop. We're just going to say I in data. We're going to print I. Remember, we have to indent that. Now if we run this again, what we should see here is everything spread out a little more. Makes it a little easier to understand. You don't have the opening and closing square brackets to show, but it might make it a little easier to understand. This is the first time we go through, this is the first item in the list, the first time we go through the complete cycle of outer and inner loops. Second time we go through the complete cycle, third, fourth, and fifth. So this is, we call it a two-dimensional list. It's a list of lists. You can do a three-dimensional list. It gets incredibly complicated after that, and there are much better ways to handle things. But it's possible to, do pretty much as many items as you want inside lists. One of the things I actually forgot to show y'all, sorry about that, is another way to add items to a list. So let's say we have dlist equals, we're going to create an empty list, right? Now if I want to add an item to that list, I can just do that, right? And, oh, wait. Nope, can't do that because, sorry, dlist equals, you have to actually create the list. You can't do it from an empty list that way. Sorry about that, folks. Now, I've created a list. We're going to look at it real fast. Right, there's our list, 1, 2, 3. Now, if I want to change the first item of the list, I can do it that way. Now if I print the list again, the first item is changed because I've changed the 0 index. That's what is pretty much happening right here. Yep, that's not, sorry, that's appending. That's the way you add to an empty list. Sorry, got myself a little confused. I hope I haven't gotten you guys very confused. Appending, which we looked at earlier, is how you add to an empty list. Doing something like this, changing the particular element, that's how you change an item in the list. So, I think we've sort of exhausted lists. I guess we can actually, I'll just show you this real fast. We're going to comment that out. We will do that. And then if this is, as we showed earlier, kind of digging into the list. We're going to grab the first item out of the list, and then grab the first item out of the list and the second item out of that list, because we know it's a list of lists. Right? Oh, sorry, run current. So, we know that this is the first item in the list, which is itself a list, and the second item inside that is 0, 1. That's what we grabbed, and that's what we printed out right there. Anyway, I hope that gives you a little more introduction to lists and how to work with those. Let's talk quickly about dictionaries. Dictionaries are a little more complicated conceptually, but they're incredibly useful. If you've done programming in other languages, you might have heard them called a map or a hash map. In JavaScript, they're just objects. Essentially, though, they are a key value pair. So, let's look over here. Ourselves a couple of empty spaces here. So when we say that a dictionary is a key value pair, what that means is it's also a collection, just like a list, but it's a collection where instead of having everything numbered from 0 to however many items are in the list, it's a collection that lets you dig into the dictionary by name, by the key name. So let's show an example. So we're going to create a dictionary called adict, and that's how you create an empty dictionary. It's just that, right? So dictionaries are in curly braces. Lists are in square brackets. Dictionaries are in curly braces. I have to keep those two separate, otherwise Python will complain to you. So let's redo this. We're actually going to fill it with something. We're going to fill it with name. So this is a dictionary that has one item in it. You see that name is the key and Derek is the value. We're going to see how to do something with that here in just a moment. So if we print adict, if we do it right, there we go. So we can see that this dictionary only has one thing in it. It has a key called name, and that key maps to a value called Derek. We can make a dictionary that's more complicated, and most often you will. So now we have a dictionary that has 3 different things in it. 3 different key value pairs here. We're just going to print this out real fast, and then we'll start looking at it, and I think it'll start making more sense once we start digging around inside there. So there's our whole dictionary, right? So before, with a list, if we wanted to create a list that represented me, we would have to do something like this, right? We would do that, and that's our list. Now, if I wanted to get to the name, or if I wanted to get to the age, I have to know that the age is the second item in the list. So I would have to, if I wanted to print my age, I have to print list sub 1, right? And that prints my age. But that requires that we know where the age lies in the list. And if this is a list of 100 different things, that's going to get really complicated for us to remember. A dictionary is much easier. All we have to do is remember that we have something called age. We have a key called age in there. Do we not? Oh, wrong dictionary. There we go. So let's look at this. What we've done is we are taking this B dictionary that we've created. You can see right up here, this is what the B dictionary looks like, right? It has a key for name and a value of Derek, a key for age and a value of 45, a key for position and a value of teacher. Now, if we want to print out my age, all we have to remember is the key, name, age, and then Python will dig into the dictionary for us and say, oh, I found a key called age. It has a value 45. I'm going to give back the value of 45. If we want to look at the position, do the same thing. We dig into the dictionary and pull out and ask for the value associated with the key position. Now, as we saw a little bit earlier, if we misspell that, we'll get a key error. Python will come back and say, I don't have a key called positio, so I don't know what to do. I'm going to throw an error at you. So just so you know, a key error is Python's way of saying, you've given me a dictionary and you've asked me to give you back a value based on this key, but I don't see that key anywhere, so I don't know what to do. You can add things to dictionaries, and it's really simple. Let's see here. We are going to add to the bdict, and you'll often hear them. Just a lot of Python programmers will shorten dictionary to dict, so you'll hear that a lot if you stay in the Python world. So we want let's take the B dictionary or the bdict, and we want to add a new key value to it. We want to add I don't know. Let's add address, right? So the way we would do that is right. So now if we print bdict, you see we have address, name, age, and position. All we had to do was tell Python, okay, let's start with the bdict. Now let's look for the key address, right? Because what you put in these square brackets, and make sure you put it in the square, you have to put it in square brackets and in quotes. That's how you get the actual key in there is in quotes. We're telling Python, okay, look at B dictionary, look for the key address and set it to Chattanooga. Python will look inside the B dictionary. If it does not see the address, it will create it on that dictionary. Earlier when I tried to add to an empty list and I messed up. I was thinking of dictionaries. You can add to an empty dictionary. You can't add to an empty list. Not the way I did it. You can add to an empty list using append. But in any case, in this right here, we are telling Python, go into the dictionary, look for this key, put this value on that key. If that key doesn't exist, Python will just create it, and that's how we got a bdict that now has address. If I wanted to change the address, I could do it the same way, use the same format, the same syntax there, and now if I print bdict, you can see that the address has changed to Nashville. So when you use this syntax with a dictionary, again, if the key doesn't exist, Python will create it. If it does exist, Python will change the value. Now, notice that when we print this, address was first. So originally it was name, age, position. When we added address, address got put at the beginning. That's not always going to be the case. Dictionaries are not ordered. Lists are ordered. Everything will go from the 0 position all the way up into the last position, and if you append, it will get put onto the end, onto the far right side. With dictionaries, it's completely random. It's not completely random. There's an algorithm behind the scenes that helps figure out where it needs to be. It looks pretty random, but it's not. But you don't need to worry about that. What you need to know, though, is you cannot guarantee that address is going to come back as the first item in the dictionary. You cannot pull dictionary items sequentially the way you can with list items. You have to pull them by key name. That is a big difference between dictionaries and lists. So if you want to delete an item, delete an item from a dictionary, you would use the del command. So del for delete. Again, like length, this isn't something you do on the dictionary itself. This is something you call separately. So you call del, and you pass in the dictionary that you want, and with the item that you want to delete. Again, spelled correctly. That, now if we go back and print bdict, we have deleted the address key off of the bdict, so it's back to the way it was originally. So those are the most of the general ways that you end up using a dictionary. Let's see here. You can also put dictionaries inside lists, like we had a list of lists earlier. Here we have a list. You can tell it's a list because it starts with a square bracket, but the items inside the list are in curly braces in key value pairs separated by commas, so those are dictionaries. So this is a list of dictionaries. And if we run this, I've done something wrong. Okay, I did not comment everything the way it needed to. There we go. I was picking up some stuff there. Let's see. Is that better? Yes. So, now what we see here is we have this list of dictionaries, and we're just printing that out, right? And that's what it looks like when we print it out. Sort of like you would expect it to look, pretty much exactly like we coded it in there. We can also comment that out. We can, because we start off with a list, we can do a for loop. We're going to loop through everything in persons and just print If we run that, we see it's formatted a little better for us. We now see each item, and we can tell for sure that each item is a dictionary. And let's see, let's get rid of that for now. Let's actually go down here and see, oh wait, I have to uncomment some more stuff here, sorry. Let's make sure that runs, yep, that's doing what I want it to do. Okay, so what we've done here is we've created a new person's dictionary. We just reuse that variable name. And in this particular case, we've made it a dictionary of dictionaries. As opposed to a list of dictionaries, this is a dictionary where each item inside where each value for the key is itself a dictionary. This is where it gets a little matrixy, right? So, if we look here at this first item in this new person's dictionary, the key is just the date, 1987, right? And, or maybe that's not a date. Maybe that's an ID number or some random number that just got generated for whatever reason. But it's 1987 stored as a string because it's in quotes. That's the key. The value on that key is a dictionary, right? It's the dictionary that has the key name with the value Lisa, the key age 29, and the key school SNHU. If we want to then go and dig in and find the name of the person who's on the 1998 key, we would do this just like very, very similar to the way we dug into a list of lists. We start with the person's dictionary. We tell it, okay, I want you to grab me the value for the key that corresponds to 1998. Since we know that that value is itself a dictionary, we can then say, okay, now dig into that dictionary and get me the person's name. And when we do that and print that out, you can see here we printed out Doug, as we should. Because if we look at the key 1998, the value for that is this dictionary, and if we look at the key name inside that dictionary, the value is Doug. So that is a little bit of an introduction to lists and dictionaries. They are both incredibly useful. You will end up using them in everything you do from here forward. I can almost guarantee it. I hope this has been very helpful for you, and I look forward to teaching you some more along the way. If you have any questions, you can send me an email or post them in our discussion board. Thanks.